This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
Hi, this is Jeremy Jung for Software Engineering Radio. Today I'm speaking with Daniel Corbett. Daniel is the Director of Product at HAProxy Technologies. Daniel has a background in high-traffic hosting environments in both a senior DevOps position as well as fulfilling the role of a senior security analyst. Daniel has worked with HAProxy Technologies for a little over a year. I'll be speaking with Daniel about what load balancers do, the different types of load balancers that exist, how HAProxy can be used, and how the roles of load balancers are changing. Daniel, welcome to Software Engineering Radio.
Thanks for having me, Jeremy. I appreciate it.
So the first thing I'd like to discuss is what load is. Could you give us a definition?
Sure, absolutely. Load is basically work that needs to be done. This could be anything from the need to retrieve information or process information or file it away somehow, but it's frequently a combination of the above. When it comes to load, some of the limiting factors could be based around CPU, disk, or network, and these are all things that servers face when they need to process load. If the load is clients asking to add two numbers, for example, the CPU will be the primary cause of the load. If it's reading or writing information stored on the server, it will be the disks. And in environments with a variety of types of load, each request can stress one component more than another, requiring careful distribution of the requests.
If that's load, then what is a load balancer and what does it do in relation to that?
So a load balancer is used to distribute traffic or load to various backend services and application servers. It takes a request and it forwards it to the backend servers, which usually reply directly to the load balancer. This allows the load balancer to reply to the client without the client knowing about the internal separation or functions of the backend network. It also prevents clients from contacting backend servers directly, which may have security benefits of hiding the structure of the internal network itself.
And is a load balancer a hardware appliance or is it a software application? What does it look like?
So a load balancer can be both, although even with hardware appliances, it still relies on some sort of software to operate in the background. Traditionally, a lot of load balancing within enterprise environments relied on a hardware appliance, but it was found that this model was not scalable or flexible and was extremely costly. With software-based load balancers, it allows an organization to run in an environment of their choosing. That could be directly from a cloud provider, a virtual machine, or even sourcing their own bare metal servers. The market is trending away from hardware appliances and heading towards software-based load balancers due to the flexibility and the scalability that's provided.
One of the things that you mentioned was that the load balancer is in front of kind of the origin application to prevent it from talking directly to your application servers. What kind of benefits does that give you?
Well, the load balancer being in front of the application server gives you the security benefit of you're able to filter particular requests. So the client would be interacting directly with the load balancer only on port 80 or 443, for example, or whatever it is that your application port is running on. And that limits exposing all of the other ports on your application to the general internet. But it also allows the backend server or application to be on an internal network only. So let's say you have your load balancer that's listening on external interface or public IP. You could have your backend network completely masked from the internet and not available at all to be hit. And your load balancer would have a route to this internal network where it can speak to the load balancers on the internal network.
If the load balancer can be placed in front and the user never needs a direct connection, does that mean the load balancer acts kind of like a proxy and, requests?
Correct.
Okay, got it.
Correct. It would act as a proxy to the backend servers, and so that helps to limit just the exposure of your application server in general. When it comes to security, it's always best to have multiple layers involved, kind of like an onion, and so the more layers of security you have, the more protected that you'll be, because even if one particular layer is penetrated, you'll be protected by another layer.
And what kinds of applications should use a load balancer?
Essentially, all types of applications could benefit from load balancing. Some common examples would be web applications and WebSocket-based applications, database systems, caching systems, mail servers, Redis or Memcached. Generally, the more moving parts the backend has and the more connections it gets, the more important a load balancer is to it.
If the requests are all coming to the load balancer, how does that not become a single point of failure?
It can be the single point of failure if there's only one load balancer configured. But typically, it's recommended to use some kind of solution or software which provides VRRP, such as Keep Alive D, for an active passive setup, which would give the load balancer a floating IP address, which will move over to the passive device if the health of the active load balancer fails. Other setups involve using routing protocols and route health injection to bring up or down advertisements based on the health of the load balancer. That would be used primarily in an active setup.
So I want to go into a little bit more detail, but before that, why don't we walk through at a high level what happens when a user attempts to use an application that's behind a load balancer? What are the steps where someone would get routed to the correct server and so on?
Sure. It would start off by a client resolving a domain name, which would return an IP address that's associated with a load balancer. And then when the client connects to that IP address, the load balancer begins processing the request. The first step of this request processing would be determining which service is associated with the IP address and the port being requested, as a load balancer can host many different services across different IP addresses or ports at one time. And if the connection comes in over SSL, there would be a handshake process in which the client would verify that it is talking to the right server. Cipher suites will be agreed upon, and a certificate and a key exchange will occur. Once both ends, the client and the server are happy that they're talking to the right person, so to speak, and have agreed on a key to symmetrically encrypt the data that they're about to send, then the request processing can move on. And then once it moves on, the load balancer then begins to perform any logic that's set up for that service. For example, if the host name being requested begins with API, the request may be sent to particular backends that only handle API requests. You may also perform logic based on a particular request URI or path to route to a particular backend based on that path. This is useful, for example, when using HAProxy as an API gateway. For example, you might have a path /catalog that you may want to send to a particular endpoint or backend, and a separate path /checkout, which you may want to send to another endpoint or backend. There may also be various security-based logic in effect to block requests coming from a particular IP address or to rate limit requests that are going to a particular path. An example of this would be if you have a login, a search, or a comment functionality on your site, you may want to limit how many requests a particular client can make over a period of time to this particular path. Then once all of the request processing logic is completed, the load balancer would then determine what load balancing algorithm is being used, round robin and least connection being the most commonly used. And then the load balancer would choose a server based on this algorithm and connect to it on the client's behalf and pass the full request to the backend server. Optionally, though, it could use persistence and route all requests from a particular user or client to the same server. And then the backend server would respond directly to the load balancer, which would then check for, again, there would be response logic processing that would happen to check for any logic that you would want to happen based on the response. For example, changing the response code if necessary. Sometimes it's used to hide server errors. Let's say that your application server output an HTTP internal server, HTTP code 500 for internal server error. You could have your HAProxy server change the status code to be a 200, which would mask the fact that an error occurred in the background. And then after the response logic processing is completed, it would then send the response back to the client.
Are load balancers suitable for any type of traffic? You had mentioned HTTP, HTTPS. But what if you're using raw TCP sockets or UDP? Do load balancers also apply in that case?
Yes, they do. Load balancers are suitable for essentially all types of traffic. HAProxy supports both HTTP-based load balancing at layer 7 and TCP-based load balancing at layer 4. When it comes to UDP-based applications, it is typically recommended to do load balancing at a lower layer using something along the lines of LVS. But we are planning to bring UDP support to HAProxy. There's a new standard coming out called QUIC, which is essentially HTTP2 over UDP. And this is something that HAProxy is also scheduled to support.
You mentioned, was it LUS? What is that?
LVS,
LVS.
or Linux Virtual Server. It's a set of integrated software components used for load balancing TCP or UDP at the kernel level. One of the main components is IPVS, or IP Virtual Server, and it primarily operates on layer 4.
I think we're going to get into specific layers in a little bit. Would you put a load balancer in front of a database or a cache, or is it more specific to your custom application code?
Absolutely. For a database, you could have the load balancer listening on a specific IP address that routes traffic only to servers that are set for reading only, and another IP address that could be used for routing to a single master server with a secondary master that is set to be a backup, and it would only be used if the primary master fails. For a cache scenario, the load balancer could be used with a consistent hash-based load balancing, which ensures that the same URI will always be directed to the same cache server, which would have the content as active or hot within its cache.
Next, I'd like to talk about the different types of load balancers. Load balancers are sometimes discussed within the context of the open systems interconnection network layers. Could you explain briefly what those layers are and how they relate to load balancing?
Sure. So the major ones for load balancing would be layer 7, layer 5, and layer 4. Layer 7 load balancers understand the application can do things like direct the request based on the host header, inject headers into the request, etc. Layer 4 and layer 5 allows routing without completely understanding the protocol, but it can still perform limited inspection for persistence and routing based on patterns found within that data. To give an example of this is, if a client comes in and you're doing layer 4 load balancing, you'd be able to only apply routing decisions based on what the client IP may be or what the destination IP may be. And or even, let's say you have a scenario where you have access control lists set up, ACLs, and you don't want to allow a particular IP to connect to your backend. Maybe you have a sensitive backend that you only want to allow people on VPN to connect to. So you could create some logic that only allows traffic from a particular IP address or blocks particular IP addresses from accessing your application server. But then with layer 7, you'd be able to go even further than that. Let's say that you didn't want a particular user agent to be able to access your application server. Maybe that's wget or curl. Just as a quick example, you may say, I don't want this particular user agent to be able to access my backend application. So you would use layer 7 load balancing to inspect the full request headers and filter those requests that match that user agent.
And does HAProxy serve both of these scenarios?
Yes, HAProxy does. Within HAProxy, there's 2 configuration modes that could be used. One is TCP, and that would be for layer 4. And the other one is HTTP, which would be for layer 7 based processing.
Would you ever use the two together? And if so, would it be in kind of a tiered setup, or would they live on the same machine? What would that look like architecture-wise?
Yeah, you can use them together. Typically, a layer 4 based load balancer would sit in front of a layer 7 based load balancer if you were going to go that route. But it's not necessary. You can have them separate from each other, but you can also combine them. Sometimes having a layer 4 based load balancer in front of your layer 7 load balancer can help when you have extremely long-lived connections and you want to load balance the layer 7 load balancers themselves, which may have established connections. You'd be able to do that easier with a layer 4 in front of it.
And if someone was looking into adding load balancing to their application, are there downsides to adding additional layers? Should they start at layer 7 and go to layer 4 after? Kind of what should be the process that someone goes through when they're thinking about adding load balancing?
Well, it depends on what their needs are. For example, if your needs are extremely simple and you don't have any logic that you need to happen based on any routing logic that to happen based on request paths or request headers or things of that nature, you can go with layer 4. But layer 7 is also beneficial even if you don't have any requirements of routing based on data found within the request. There's some security features that come with it, allowing you to filter particular content or activate a web application firewall, for example, things like that. I'd say that from my perspective, layer 7 is always great to use. But if you're just getting started in load balancing, layer 4 can be appropriate too if you don't have any specific needs. Again, like if you don't need an API gateway or you don't need to do any request processing or response processing or inspection, layer 4 can be suitable. It's a tough one to answer because I think every user's needs would be different, basically. So I think that you couldn't go wrong with using either of the two. But with layer 7 load balancing, you get a lot more flexibility and power when it comes to handling requests.
If you don't have any particular requirement for the things in layer 7, it may still make sense to start with that just because it gives you the flexibility to use those if you find out you do need them later.
Right, exactly. And just to go a little bit further into it is that HAProxy fully supports the HTTP protocol. So you would gain the benefit of the protocol understanding capabilities, which, as we mentioned above, it allows you to route based on the information found in the request, but it also allows you to add or remove headers or rewrite the request itself. So there's a lot of just benefit within layer 7 in general. So it's typically, and especially in the current climate of application servers, it's typically a lot more beneficial to start with layer 7.
Next, I'd like to get more into the specifics of HAProxy. First, what is HAProxy?
So HAProxy is the world's fastest and most widely used software load balancer. It provides an extremely fast, reliable, and flexible solution offering high availability, load balancing, and reverse proxying for TCP and HTTP-based applications. It is particularly suited for very high traffic applications and powers quite a number of the world's most visited ones. Over the years, it has become the de facto standard open source load balancer and is shipped with most mainstream Linux distributions and is often deployed by default in cloud and microservice platforms.
Why was HAProxy originally created, and what kinds of gaps was it filling?
So HAProxy was originally created and known as ZProx, which was just a compressing TCP proxy which supported gzip-based compression. It was created by Willie Thoreau in 1998, and then in 2001, he added persistence to offload a failing load balancer that he was working with, and HAProxy 1.0 was officially released. Prior to HAProxy, it was common for organizations to just use pure hardware-based load balancer.
So would that have been devices like the F5 hardware load balancers?
Correct. Okay. Yep.
And like you were discussing earlier, it sounds like that's becoming less and less common now, I guess due to the flexibility of software load balancers. Is that correct?
Yes, it's the flexibility and scalability that they provide in general, because typically when you were buying a hardware-based load balancer before, you would have to plan how much capacity you may need. You'll have to estimate what your traffic needs are, not only now, but maybe a couple years into the future, because a hardware-based load balancer could be quite expensive and costly. And we've talked to many customers of ours who, over time, they weren't able to make the appropriate decision. They thought that their traffic level was going to be one way, but then they ended up having a lot more traffic or a lot less traffic. And each of these can impact the organization in a particular way. So if you don't plan accordingly and you have a lot more traffic than what you originally provisioned for, well, now you need to purchase another very expensive piece of hardware to extend on. But also there's some traffic patterns that, maybe in some cases you have burst type traffic. Let's just think of a situation where maybe you're running an application that the peak traffic bursts on the weekend, but during the week you don't have much traffic. Or think of situations such as Black Friday. We all know to be an extremely popular shopping time in the United States. And, do you need to buy an additional hardware load balancer to accommodate for that peak traffic? Or what? The software load balancer provides the flexibility and the scalability to scale up or down as needed based on your traffic demand.
And that's primarily because you're using commodity hardware as opposed to specialized machines?
Yes. You could source your own commodity hardware, but you can also deploy in a virtual machine environment, for example. Maybe you have a couple beefy servers that are already configured to host virtual machines. You can deploy your load balancers there and scale them up or down, or also similarly within cloud-based markets. So, you can deploy within AWS or Google Cloud or Microsoft Azure. And so that allows you the flexibility to scale up or down based on your application's needs.
We discussed a little bit about how HAProxy supports layer 7 and layer 4 load balancing. What are the cases where there would be load balancers upstream of HAProxy? I think you had mentioned that DNS, for example, could possibly serve as a load balancer. What would be serving that role?
Upstream, the two most common ways to handle this would be either using global server load balancers, also known as GSLB, which is based typically on DNS, and also BGP Anycast. So the first one with GSLB solutions, an example of this would be AWS Route 53, which uses intelligent DNS to direct clients to specific locations based on the client's location. For example, if a user in Europe performs a DNS request to your site, a GSLB solution will respond to the request with an IP address from your particular European point of presence. There are open source solutions that provide this, such as PowerDNS is one with a GeoIP backend. If you want to try rolling your own DNS GSLB setup. The second solution that I mentioned, BGP Anycast, it relies on the fact that routing decisions on the internet are based on the shortest autonomous system path or AS path. With Anycast, you announce the same prefix to the internet from multiple point of presence locations. So when a client makes a request, they get routed to the point of presence closest to them. To utilize BGP Anycast, your infrastructure needs to have the ability to speak BGP with your upstream provider, so you can advertise your Anycast prefix. But also, since the smallest prefix that you're allowed to advertise on the internet is a /24, you will need to at least have a /24 that you can dedicate to Anycast. But once you probably heard me mention multiple times points of presence within this. When you have multiple points of presence set up within each of these locations, that's where you would have your multiple active HAProxy setups running. So as I had mentioned, if you have a user in Europe that performs a DNS request and they get sent to your European point of presence, at that location, you would have as many HAProxy instances as is required for your traffic level. That could be 4, it could be 8, it could be 10. But this would allow you to essentially load balance your load balancers globally.
Basically, whenever you have more than one HAProxy instance and you want the client to be able to, like you said, be load balanced to each of those, you would use either the BGP Anycast or the GSLB, and that's how the client would get redirected to one of your HAProxy load balancers.
Correct. We typically see this setup in extremely high traffic environments, such as ad tech companies are a big one. We have a few ad tech customers who serve billions of requests per day, and they have global network and global platforms and things of that nature. So this is the common setup for some of the world's largest sites.
If you're a smaller organization, does that mean that you would only have a single HAProxy load balancer? I'm trying to picture what that looks like.
No, it's typically never recommended to just have a single load balancer active. What we find some of our smaller customers use is an active passive setup. And with an active passive setup, you would use a software such as Keep Alive D that would help to fail over an IP address from one server to another. So you would have your active load balancer and then your passive load balancer. The active load balancer would have the IP address at all times, but using a software such as Keep Alive D, you would be able to detect what the health is of the active server. And if the active server fails in some particular way, the IP address would automatically move over to the passive device or server.
I see. So you would be running more than one, but it would actually be one fielding all the requests until the second passive server detected a problem with the active.
Correct. And that's what we find some smaller organizations are using that don't have so much traffic at the moment. It's the easiest to set up and get going, and it doesn't require you to have a network engineering team to make the magic happen.
You had mentioned Keep Alive D. Could you explain kind of at a high level what that is?
So Keep Alive D is essentially a routing software that it allows you to have an active and passive setup for an IP address. So what you would do is you could have it monitor a variety of circumstances. So you can have it do health checking on its local instance to know if the application is still running. Let's say if HAProxy is still running or something of that nature. And then simultaneously, the secondary server is doing pings at a low level protocol to establish itself whether the active server just spontaneously crashes, for example. And Keep Alive D would be running on both the active and the passive server, and each server would have a priority set to it. So your active server would have a higher priority than your passive server. And if something fails on the active server, the passive server would automatically take over this IP address with Keep Alive D. Keep Alive D would essentially move the IP address to the passive server.
Next, I'd like to go into how a load balancer selects which server to pass the client's requests onto. Earlier, you had mentioned round robin. Could you define how round robin works and what some other options might be?
Sure, absolutely. So with round robin, each server is used in turns according to their weights. This is the smoothest and the fairest algorithm when the server's processing time remains equally distributed. Some of the other algorithms that I can talk about are least connections. And with least connections, the server with the lowest number of connections receives the connection. This algorithm is typically used where very long sessions are expected, such as LDAP, SQL database servers, or Microsoft Terminal services. But with that said, I'd like to go into a few other of the load balancing algorithms in general, because HAProxy supports a wide variety of other load balancing algorithms, such as random, which selects a server at random while respecting the server's weights. There's also source load balancing, where the source IP address is hashed and divided by the total weight of the running servers to designate which server will receive that request. And what that does is it ensures that the same client IP address will always reach the same server as long as no other server goes up or down. But the options are endless when it comes to load balancing algorithms within HAProxy, as it can also load balance off of a specific request header or a URL parameter or anything for that matter.
You mentioned a weight for the server. How is the weight determined?
The weight is something that would be determined within the configuration. So it's typically used if you have different servers with, let's just say, different hardware specifications. Let's assume that you had a setup where you had some old servers, back-end application servers set up, but you started purchasing new hardware, beefier and better. you don't want to equally distribute the load to your new beefier servers at the same level that you're distributing the load to your older legacy servers, let's say. So with that, you would use weight to send more of the requests to the newer hardware and a fraction of the requests to the legacy hardware.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio.
And how can HAProxy tell if a server is in a faulted state, if it's either not processing requests at all or is processing them very slowly?
Yeah, that's a great question. And this is actually where load balancers shine in general, and HAProxy itself does actually. So there are several options when it comes to dealing with health checks within HAProxy. You could do active health checking, such as a simple TCP port check, a service-specific health check for things like MySQL or Redis, or even send a full HTTP request and search for a pattern within the response or a response status code. So, for example, when you send a full HTTP request and you're looking for a particular response, maybe you have a status page up. Let's just call it status.html. And let's say that typically this status.html page would contain the string OK. HAProxy would connect, fetch status.html, and then it would look for the string OK. But if it found any other string, such as fail, or it didn't find any content within the file at all, or it didn't receive a response, it would consider that server as unhealthy. But to go further a little bit into that, HAProxy also allows you to send a particular string and match the response against the pattern on other protocols that are not HTTP. So this allows for testing just about any protocol, whether it's ASCII-based or binary, and it also allows you for testing multiple ports. And another active health check that's extremely powerful is called an agent check. And in this case, an administrator would configure an agent that would run on a backend server, and it's checking a variety of aspects on the backend server. It's possibly monitoring the load, the memory usage, or other local server metrics. And then the agent has the ability to adjust the weight of the server. For example, if the load starts creeping up, the agent can lower the weight so the server gets less traffic, or optionally, it can remove a server altogether from a receiving request until the server has recovered. And finally, HAProxy also offers passive health checking. And passive health checking essentially allows HAProxy to monitor what kind of responses that application is sending to the client. And if it starts seeing an application generating too many errors to a client, once it hits a defined threshold, it can automatically disable that server from the cluster for a period of time. This would be activated within HAProxy using what's called the observe keyword. So you can have this activated simultaneously with active health checks. So you could be performing your active health checks, but the passive health checks to catch situations that maybe the active health check is not generating, where an application begins generating an anonymous amount of errors to a client.
And these configurations you're talking about in terms of checking for specific headers or specific content, is this configuration in HAProxy, or is there some ability to actually program logic in HAProxy? Like, how does that look to the person who's setting this up?
Yeah, most of it would be just a configuration line within HAProxy. It really depends on what you want to do. For an agent check, for example, it'll require a configuration line within HAProxy, but it would also require that you have an agent running somewhere that's answering HAProxy would connect to the agent, and the agent would need to respond accordingly with the proper data. But yeah, typically these would all be configuration options that you would apply, but they're very easy and simple to use or get started.
Next, I'd like to talk about a few other scenarios. We talked a little bit about whether a client will connect to the same server on subsequent requests. Is that just something that you would configure at the load balancer level? How would you determine whether or not the client gets the same server or not?
It depends if you want to have persistence. It's not always required. So if you do intend to serve persistence, or you do require persistence, there are several ways that it can handle it. So one could be persistence can be maintained using the source IP address of the client, a cookie, or it can also use any kind of data fetched from the request and stored in something that HAProxy calls stick tables.
Next, I'd like to talk a little bit about designing an application with the load balancer in mind. When someone's designing an application, what are recommendations you have to make sure they can take full advantage of a load balancer?
Essentially, there are a few things that a developer can do to ensure that their application is compatible with a load balancer. And that typically involves not storing any particular client data or that's needed for the application to work locally. You typically want to store this data within a centralized database or object stores such as Memcached or Redis, things of that nature. Those are the primary tips, is just to not store any data locally.
So basically minimizing any kind of state, and that will make it so that the load balancer can call any kind of server, which really gets you the full benefit.
Correct.
How does the load balancer stay aware of what servers are available? Is this something that somebody would enter IPs into a config file, or is there some other method?
So there's a few methods that are involved. So the most common method has always been, you add the IP addresses to the configuration file, and then the load balancer would be aware of the new server. But there's newer features that have evolved. One of them involves using what we call the runtime API within HAProxy. And the runtime API operates off of either a Unix socket or a TCP-based socket. And within the configuration, you would essentially establish what we call a server template. And the server template would essentially say how many servers you would expect to scale to. And you can leave padding in there. So let's say, you think maximum you'll scale to 20. Well, you can set this to 30 or 40 or whatever it may be. And then you would use the runtime API to actually establish a server. So the server template I mentioned would kind of be like a placeholder. And then you would use the runtime API to actually set a real server IP address and port combination to activate that particular server within the load balancer. And this can be automated. As I said, it's a Unix socket or a TCP-based socket, and it just accepts and sends ASCII information, ASCII data. But then there's also another method that HAProxy supports, and that's called DNS service discovery. And DNS service discovery allows HAProxy to be configured to look at just a host name, and that host name would be either an SRV record or an A record, and both of these would contain multiple records within them of all the servers that the application should serve to. And then this integrates great with products such as HashiCorp's console, for example. But when using this, we typically find that the SRV records are the most powerful feature to integrate with, because the SRV records allows you to define multiple things within it, not only the IP address, but the port that the application is listening on, as well as the weight that you want that application to have within the load balancer.
So it sounds like, just to summarize, from the simplest, there's a configuration file Next, there's a runtime API where the developer could actually have an application that was communicating via sockets to HAProxy to tell it what IPs are up. And then finally, there's kind of pushing it all to DNS, where HAProxy will check the SRV records at the DNS level to know what's available and what's not.
Yep, absolutely.
Next, I'd like to talk about HAProxy in the context of the load balancing ecosystem. I think a lot of people are familiar with Nginx and how it's a web server, but that it also serves as a load balancer. How does HAProxy's role differ from the role of Nginx?
HAProxy was built from the ground up to be a load balancer. We're very proud to do one thing and be excellent at doing that one thing. The primary difference of HAProxy over Nginx in the terms of load balancing is that it is faster and more efficient while using less resources to do so. And this information is easily found online from a presentation that Booking.com did when they were interested in switching off of their F5 device, and they were comparing HAProxy versus Nginx, and they performed non-biased benchmarks to figure out which application load balancer was the best for them. And they published these online, and they did a presentation at a conference at some point on this. And within their presentation, it shows that HAProxy was not only faster, used less CPU usage, but also allowed for more connections in general. One other major difference we find when we compare HAProxy to Nginx is that Nginx does not have a full-featured logical operator support. Their mantra is "if is evil." And you'd be hard-pressed to use the "and" operator when performing complex logical decision. Any system administrator, system engineer, or DevOps person who has experience with the Nginx configuration file is probably fully aware of the limitations that it has when it comes to using if statements again. Whereas HAProxy fully supports if, and, or, as well as not operators, allowing a user to have full control over the decisions that are made. And we actually encourage the use of these logical operators, as this is how you could take advantage of some of the most complex, or take advantage of some of the very complex and advanced routing or logic decisions that could be made by HAProxy.
Next, I'd like to kind of compare HAProxy to the fact that a lot of cloud providers are now providing managed load balancing services. You have Google Cloud Load Balancing, there's Amazon Elastic Load Balancing, and Azure. And so there's all sorts of cloud services that are providing load balancing. How do these managed services differ from HAProxy?
So we find that these services only allow a small control over the decisions users would like to make when load balancing. Typically, they're in the form of just a few checkboxes. Within HAProxy, the decisions are endless. We give you the building blocks to build what you like. We do find, though, that these services can complement HAProxy by sitting in front of it as a network load balancing layer, such as Amazon's NLB, their network load balancer.
And so it sounds like you might want to use them in conjunction. I believe you had also mentioned before that Amazon provides DNS-based load balancing with Route 53. So in that case, they would be serving the role of, would it be a layer 3 load balancer in front of the HAProxy load balancer?
Yeah, so using it in that scenario, it would just help to bring you, an active setup of HAProxy instances.
Recently, there was a new load balancer or service proxy built called Envoy. Are you familiar with the project, and how do you feel that it differs from HAProxy?
Yeah, we are familiar about it. Envoy is a new player to the game, as you say, and it's going to definitely be interesting to watch it as a product to mature and grow. But we found that in many areas, they seem to be working backwards on the technology where we're working forwards. And what I mean by that is it appears that they've added a lot of the newer hyped technology first to gain attention. And that now they're working backwards and adding some of the basic load balancing features that many have come to enjoy and find necessary when it comes to load balancing. At the moment, their product is still very young, so it's hard to judge where they will be in the future.
Finally, I want to talk about how load balancing has kind of progressed and its future. When load balancing first started, application architecture was typically monoliths. And then as we kind of progress, there's been more of a service-oriented architecture or a microservices type of design. How has that changed the role of load balancing?
So yeah, you're absolutely right. Load balancing has changed tremendously over the last decade. We've seen the switch from layer 4 load balancers to application delivery controllers, or ADCs, which are layer 7 reverse proxies, but still on a hardware platform. And then we've seen the move over to software-based load balancers. Traditionally, organizations would purchase a hardware load balancer and would need to estimate their levels of traffic, as I had mentioned earlier, well into the future when making these purchases. From there, it moved to running software-based load balancers or bare metal servers and virtual machines, both hardware-based or software on bare metal, and also software on virtual machines, as again. But at this point in time, they would still be serving a monolithic application. And from there, load balancers moved into the cloud or continued to run on bare metal servers and virtual machines, but with the backend application being a microservice or microservices. This brought a whole new set of requirements in terms of service discovery, as we had discussed. One popular way to handle it, as I mentioned, is through DNS using SRV or A records. And then microservices brought containers and container orchestration platforms such as Kubernetes. And then containers showed a rise in the sidecar proxy, which would run alongside your application container and speak to the application directly, while you would have your edge proxy speaking directly to the sidecar proxy.
You mentioned containers and container orchestration. Kubernetes provides a form of load balancing, but then you also mentioned how HAProxy could be used as a sidecar. How does the use of HAProxy relate to the load balancing that exists in Kubernetes?
So Kubernetes allows you to plug in different software load balancers. And HAProxy supports Kubernetes with its community-made and commercially supported Ingress controller.
To close us out, could you summarize the benefits that developers get by employing load balancing?
Absolutely. So having a load balancer within your infrastructure can increase the scalability, and specifically the scalability of your backend application servers. It will provide redundancy and reduce downtime with increased performance, and give you the ability to efficiently manage failures. It also provides increased flexibility when it comes to advanced logic or routing decisions that you may need to apply. And finally, it provides a centralized application security at the edge of your network.
Finally, how can people follow you online?
You can follow me on Twitter at Daniel Corbett _. My last name is spelled C-O-R-B as in boy, E as in Edward, T as in Tom, T as in Tom. So again, that's at Daniel Corbett _ on Twitter. Or you can also find me on our community Slack chat, which is found at slack.haproxy.org. Or if you prefer to use IRC on the free node network, #HAProxy.
Daniel, thank you so much for coming on the show. We had a great conversation, and I look forward to seeing what comes next for HAProxy.
Oh, thank you so much for having me. I really appreciate it. It's been great.
This has been Jeremy Jung for Software Engineering Radio. Thank you for listening.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity and high performance with no billing surprises. Try DigitalOcean for free by getting a $100 infrastructure credit at do.co/SERadio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.